Hello students, today's topic is heating effects of electric current. Actually, it is the process of dissipation of source energy in the form of heat. Student, suppose you are given one circuit like this, and in this circuit R is the resistors of resistance which is connected across the terminals of a battery which provides potential difference V and current I flowing through the resistors in time t. So student, if total amount of charge flowing through the resistors R is Q, then we can write I equal to Q by T, and Q will be equal to IT. Next, total amount of charge Q through potential difference V needed some work. So student, work done to moving charge Q through a potential difference V will be W equal to VQ. So in place of Q we can write IT. Next, back to Ohm's law. So Ohm's law states that V is directly proportional to I. That means V will be equal to IR. So in place of V we can write this IR into IT. So I square RT. So student, again we can get I equal to V by R. So simply put this here in place of I. So V by R whole square to R into T. So V square by R square into R into T. So student, here we are getting V square by R into T. So student, if the circuit is purely resistive, then work done is converted into heat energy of the resistor. So we can write here H equal to V square by R T. So simply we can write here W equal to H equal to VI T, after that I square RT, and at last V square by R into T. So student, Joule's law of heating states that number 1, H is directly proportional to I square. That means heat produced in a resistor is directly proportional to square of current passing through it. Next point, heat is directly proportional to resistance, and the third point is heat is directly proportional to time. So simply we can write H equal to I square R T. So finally we are getting here H equal to I square RT equal to VIT equal to V square by R T. So student, two factors which are mainly responsible for heat generation in a wire of given material are number 1, magnitude of current, and number 2, resistance of the wire. So if high amount of current is allowed to pass through the wire, then rate of heating of the wire increases, and if the given material of wire has higher resistivity, then rate of heating increases. So student, next one numerical. Suppose 1 J of heat is produced per second in a 16 ohm resistors, then what will be V, that means potential difference. So students, simply apply the formula H equal to V square by RT. So here we have to find out the potential difference V. So V will be equal to root over H into R by T. Now put the value 100 into 16 by 1. So student, after calculating, we will get the value 40 V.